Hi, friends. My guest today is Jim DeKloe. Jim is a teacher at Solano College. He's played a crucial role in establishing the biotechnology programs there, including the new bachelor program in biotechnology and biomanufacturing. He's also played a big role in getting funding and sort of tying together this public-private partnership that has helped establish Vacaville as being a center for biopharmaceutical manufacturing in Vacaville, which is sort of on the edge between this rural farm area and the outskirts of the San Francisco scene. And Jim is one of those people that's incredibly smart and really experienced, and it was really an honor for me to be able to get a chance to interview him and talk to him and pick his brain. He is really supportive of the diyBio community. He has some really good thoughts around the bioethics associated with how the diyBio and the larger biology space can work in tandem to make sure that the technology is used the right way to improve our lives. And what I also like about him is he's very optimistic. He's optimistic about the future of humanity and the ability for our society to get up to speed and make intelligent decisions about policy and applying the technology. And it's really good to be able to talk to someone like that, because for me, sometimes I can get a little bit pessimistic about the general public. So to meet someone who's in touch day to day with new learners and really is a big believer in the potential for the technology is pretty cool. And like I said, he's a big supporter of the diyBio community and definitely sees a place in them filling the gap between working on projects that maybe don't have a lot of corporate or investable interest. And that's really what a lot of us are doing. A lot of us are tweaking and working on things that maybe don't quite have a business opportunity attached to it yet. But all of the science that this community is doing, it is actually making a difference. And there are a lot of really interesting things in synthetic biology that are going on that are directly rooted and informed in the things that DIY biologists are doing. And Jim's really able to really tap into that. He also has an incredible personal story about his son and a medication that he helped develop that saved his son's life. And so you're really going to want to hear that. It's pretty incredible. So without further ado, Jim DeKloe, ladies and gentlemen. All right. Well, Jim, thanks so much for joining the Everyman Bio podcast. It's a pleasure to have you on the podcast. Let's start with like how we normally start, which is tell everybody about who you are and what you do.
Thanks very much. My name is Jim DeKloe, and I teach biotechnology at Solano College. And we have several campuses, but our biotech program is based in Vacaville, California. And that's natural because Vacaville has become a center for biotechnology, more specifically for the manufacturing site, for the manufacturing sector of the biotech industry. And so we get the companies when they're very mature, after they've done research, after they've done development, after they have products that have gone through the pipeline, have gone through clinical trials and have been approved by the FDA, and then you have to produce them to large scale. So that's what happens in Solano County. That's what happens in our town. So when Genentech announced that they were going to build the largest cell culture biomanufacturing firm in the world in our county, I went to them and I said, I'd like to start a biotech program in order to supply you with technicians. And they said, that's great. What are you thinking of teaching them? And I went through kind of a typical research and development type of program that I was thinking of, something that I didn't in graduate school. I went to UCLA and worked in molecular biology, and they said, yeah, that's not what we do. That's done by PhDs in the Bay Area proper. What we do is once you have the cells genetically engineered, you grow them up in these gigantic tanks, you have them produce the proteins that become the medicines, and then in this gigantic scale, you isolate those proteins to purity, bottle them, and those are what you're going to send off to patients. And all along, you have to comply with FDA regulations. You have to be carried out, these processes have to be carried out under good manufacturing practice, which is a very strict paper trail for them. And that's what you have to teach. And I said, well, that's all well and good, but I don't know any of that. And they said, well, come on down and learn it. Really? Don't offer if you don't mean it, because I've got a sabbatical coming up. And they said, no, we mean it. And so I went down and dove headfirst into what's now called biomanufacturing, although at the time the term hadn't been coined. And so I brought that back, and now we have a comprehensive biotech program that I'll talk more about later, that trains people to go into the field of biotechnology, especially into what's now called biomanufacturing.
So it seems like it's been a decades-long process for you personally, and both in creating this bachelor program at Solano Community College, as well as establishing Vacaville as a sort of a new hub in biotech R&D. And for folks who don't know, because I had to look this up myself, where Vacaville is located is a bit north of San Francisco, right? And is it? Would you say it's pretty rural?
No, it's more suburban.
Suburban.
When I first moved to Solano County, it was rural-ish and suburbanizing. So anyway, I grew up in the San Fernando Valley of Los Angeles, and it's not really very different than where I grew up. So it's suburban. So Solano County is halfway between San Francisco and Sacramento. It's halfway between UC Berkeley and Davis, if you have an academic bent. And so we're kind of in the middle, where the area where the bay turns into the Central Valley. And so Vallejo and West Solano County has a very Bay Area feel. It's on the bay, where East Solano County, sort of Dixon into Davis, has a Central Valley feel. And we're right at the transition zone. And what's nice about Vacaville is it's close enough to the Bay Area where the intellectual property can be easily transported over, and the people there, it's an easy drive for them. On the other hand, it's out of the Bay Area enough that the land is less expensive and the cost of living is less expensive. So it sort of has the best of all possible worlds.
Definitely seems like a big win-win, because it provides new jobs and new economic opportunities, especially for young people that you're educating, but also for the entrepreneurs and businesses in San Francisco, where it's just inordinately expensive there to do business, especially biology-related R&D. Well, tell me about this process. Like, how long has it been? And I was reading some articles about your role in getting some grant money for establishing this new big biotech center. Could you maybe tell us a little bit about this new partnership between the city and getting the grants and the college, about making Vacaville in this particular area a new hub, if you will, for biotech? Right.
So the city of Vacaville has been a hub for biotech. The new establishment of the California Biomanufacturing Center is trying to put that on steroids. To really become a world-recognized region for biomanufacturing. And again, early on, Vacaville in the 80s had a small company called BioSource, and that became big, large-scale biology, but then it ran out of money and went out of business. But they parlayed that into attracting Alza, which was purchased by Johnson & Johnson. And that's more of a traditional pharmaceutical company, but again, emphasizing biomanufacturing. And then they proved that, the city of Vacaville proved that they could go through the permitting process pretty easily, that they knew what biotech was. And so they parlayed that into attracting a Chiron, whose headquarters is in Emeryville, a Chiron manufacturing plant. And then they parlayed that into Genentech, attracting Genentech Vacaville, which is, again, as I said, the largest in the world. And so now the city has really taken the initiative in a partnership with Solano College to start a nonprofit called the California Biomanufacturing Center. And what we're doing is traveling around the country, talking with CEOs. Would you like to, if you're going to expand, would you consider coming to California? and again, I don't think regionally, I really think statewide, and I think nationally, and really I think internationally, that everyone on the planet will benefit from the expansion of this field, and we just have to go. But I'm focused locally. It's that old idea of act locally, think globally, and so everyone has to get into this. And you mentioned young people. This is a tremendous field because it has great opportunity for upward mobility. If somebody is especially living in California, and especially living in the Bay Area is the birthplace of biotechnology. That's where the science of this field came out, and that's where the business side, which is equally important, came out. You had venture capitalists who were willing to take a risk. Young entrepreneurs came in and they said, we'd like to commercialize what's going on in the laboratory and start a pharmaceutical company doing this differently, making medicines using living cells rather than mixing chemicals together in a big tank and having them undergo inorganic chemical reactions or organic chemical reactions. And the venture capitalist said, okay, new pharmaceutical company. The common wisdom is that no one is going to ever start a pharmaceutical company ever again because the barrier to entry is too great. It just takes too much cash. But you think you can do it? Yes. You think you can get bacteria and then later other types of cells to make medicines? Yes. Are you sure you can do it? No. And they said, well, what the heck, we'll give you some money. We gave money to these two guys in a garage on the peninsula making computers in their garage, and that worked out okay. So sure enough, and really it was the entrepreneurial spirit, the high risk, I'm willing to take a huge risk of the Bay Area that really made this the center of the world in biotech, and it spread from there. So if you have a young person in the Bay Area, you're in exactly the right place. And right now, with all the advancements, with the expansion of the field, you were born in exactly the right time.
That's fantastic. And you know, I love when there's a public-private partnership, especially when you bring in the education factor, all working together towards a common goal. It's a win-win all around.
Absolutely. And think of the impact, to California and to the community, that we are a relatively poor county, and our students come from very modest means. And this is the American dream. You come to our education process. We have a certificate. We have an associate's degree. As you said, we have a new bachelor's degree. And we have a partnership with several universities to go into a graduate degree, and we're reaching out to our local high schools. And so we have an entire pathway: high school through community college, bachelor's degree, graduate degree, through a PhD, alpha to omega, and you can get the companies to pay for it. So you can, because California community colleges are so inexpensive, you can exit college without debt and enter into this field that has tremendous potential for upward mobility. So when a student comes to me and says, I just got hired, this is my first job, and I said, don't think of it as a job, you entered a career, because you can move up, move up, move up. Very often, the head of the plant started out at technician level 1.
That's a great life hack because of that partnership with the private industry.
Right.
It's you're getting hands-on education and almost an assured pathway to a job, which is not the case for so many people that are in school right now spending lots and lots of money.
We have 100% placement. And again, for the companies, they interact with us. This is the curriculum that we would like. And so we provide that curriculum, and then the incoming employees that they bring in know what the job is about. They know what to expect. They know the background information on every process. They can troubleshoot. They have worked on equipment in our training facility, which is comparable. And so they can hit the ground running rather than taking 6 months to train, and they can be productive that much faster. And in the business world, which moves really fast, that's a major advantage.
Yeah, that's fantastic. Why isn't this model being deployed in other parts of the country across other disciplines?
No,
I just don't seem to hear about it very much.
Oh, well, it's the best kept secret or the worst publicized. But no, we are on speed dial. For example, today I was talking with my colleague in the Philadelphia area and my colleague in San Francisco, and we're networked in North Carolina. Boston has a huge Biotech Hub, and we're networked there. San Diego, I interacted extensively with last week. Seattle, and so we are networked all across the country. There are comparable programs, and what's nice is the faculty all share curriculum. It's a communal activity. There's no competition because everyone knows that what we have to do is expand the workforce, or else there's the threat that there will be therapies that won't be available to patients because we won't have the people to produce them.
Mm. If we look at the entire field of biotech and we were to sort of segment out of it or break it up into segments and say biomanufacturing, where does biomanufacturing fit with everything else that's in biotech?
Biomanufacturing is usually the purview of a fairly mature company. So in the San Francisco Bay Area, there are many hundreds of biotech companies. Many of them are startups. And so they'll be in the research area where they are looking at the fundamental science, but really an application of fundamental science to a particular problem. From there, you move into development. Okay, I've genetically engineered an organism. Now I have to optimize the conditions to allow them to grow to the maximum amount, maximum number of cells per liter, and then to maximize the amount of protein, and then to isolate that protein to purity and get the maximum amount of yield. From there, you move into clinicals, and by the time you're in large-scale manufacturing, you're 7 to 10 years down the road. You're in a mature company, and usually that's what I focus on training students to go into. But there are job opportunities at every one of those stages.
One of the trends that I see in our economy, and this is probably not a surprise to you, is a trend towards automation. And that's had a big impact on the economy and availability of jobs, especially for young people. What do you think, is that an issue or is that a risk for biomanufacturing? Yeah, I know there's some biotech startups that are working on just automated wet labs, for example, where you can write some code, you can design experiments, send it to them programmatically, the robots run it and give you the data back. How do you ensure that these cohorts of students that are going through this program are protected from being automated out by software technology?
Yes, so that's something I think about a long time. I think about a lot. So we have a grant with the National Institute for Innovation in the Manufacturing of Biologics for automation in biotech. So we're immersed in it and developing curriculum to train people in automation. The hope is that the automation will take away the boring part. So the routine part. Okay, we're going to automate that out, and what humans will do is the more interesting part. But you're correct. You're exactly right. Very astute comment. Students ask me all the time, am I going to be automated out of a job? And my answer is probably not. But I have less fear for you than I have for supermarket checkers, the people taking your order at McDonald's, bank tellers, go down the list. So every element of our economy is at risk of automation, replacing people, and I have less concern over you than I have for them, if that makes sense.
Yeah, absolutely does. The training's incorporating the specialization, and there is something about biology that can be a little difficult to automate. You need the ideas, you need the intellectual innovation to happen. You can't really train a robot to do that. But I imagine you have to adapt, or you've had to adapt to the curriculum and what you teach over the years as to sort of to shield from that, protect from that. Sort of like, okay, well, we see the robots are coming, so we're now going to teach you how to build the robots or design them as a way of sort of protecting from that.
But you better understand them and how they work. And so In biotech, the big thing now is, building in machine learning and having artificial intelligence, the industrial Internet of Things. And so everything that you're learning about in other fields, that's being brought into biotech as well. So just learn the automation, right?
Yeah.
If you know the automation, you're not going to be automated out. And you're correct. Now, the other thing that I thought you were going to is what are the chances of me being, of my job being moved overseas?
Oh, I didn't know about. I'm not
Oh,
familiar
okay.
with that, and I
Well,
don't hold any opinions. So educate me.
oh, well, so the answer is the same. I think in this field, your chance of your job being moved overseas is less. I have less fear of that than I do in other
I would imagine the
industries.
same jobs that you can outsource overseas are also the same jobs that are at risk of just being automated in general,
Yeah, correct.
since you can
Yeah.
sort of package it up in a discrete sort of set of procedures that you could just send off.
And if you look at the field of biotechnology, everyone thinks of it as being sciencey, but it's less sciencey than that. It's an equal amount of business. It's an equal amount engineering. It's an equal amount compliance with government regulations. So especially in the pharmaceutical manufacturing field, the Food and Drug Administration has very, very strict regulations on the manufacture of any pharmaceutical, but especially biologics in this field. And so to a large extent, it's difficult for the companies to comply with that and expensive. They do, but it's expensive to comply with that. But to some extent, that helps to maintain domestic biomanufacturing because it's harder for international companies to comply with American regulations, maybe, than it is for American companies. So that helps keep things at home.
Yeah, that's interesting. So there's some context-specific things in biotechnology that you have to learn in order to be successful there. And I want to come back to the policy stuff because I think there's probably a lot of conversation around policy in the United States related to biotechnology that we could talk about. But one of the things, being that my background's in software, I'm interested in hearing a little bit more about that particular facet of the education today. Is everyone, are all your students at least part of the bachelor program? Are they having to learn to code? Is learning machine learning and AI, is that part of the curriculum now? Maybe could you talk a little bit about what is being taught specifically, if you have insight into that? And what are
I'd say that's a weakness, and that's why this grant that I'm part of is delving into that. So it's a weakness across the United States, I think, in training is looking at the automation and all the software behind automation.
I would absolutely agree with that. I think in general, just supplying the demand for software engineers is definitely in short supply and has been for a while, and that's driven the salaries for tech workers just astronomical. Where, as I noticed in biotech, if you just go to Indeed, which is sort of like my favorite job searching website, and you type in biotech and you look at the job listings, what the pattern that I will see is they want a lot of education, which, as we know, can be quite expensive depending on how you go about doing it, and they don't pay as much. And it seems a little bit out of balance compared to the software engineering world, where you can take a boot camp, maybe you can build out a little portfolio in your free time, and you can get a six-figure job as one of your first real jobs outside of school, if you even went to school. Why is there such a big disparity between those two? Especially now, there's becoming to be more overlap in terms of the skill sets.
Well, there's a big disparity between high tech and everything, right? So biotech is pretty good. It's just not compared to that. But let me talk about salaries in biotech. So entry level, you're going to start in the mid 40s. And then if you add a shift differential, because when you first get hired, you're probably going to work in a swing shift or a graveyard shift, because those with seniorities take the day shift. And so that's a shift differential about 15 percent. And then often the biotech companies will run 3 or 4 12-hour days, 8 hours, but those extra 4 hours are overtime by law. And okay, well, now you're getting up there, and that's the start. And then when you move up and shift lead, supervisor, manager, when you're at the manager level, then you are in the salaries that you're talking about. And so it may take you longer, but again, this is a field with tremendous upward mobility.
Yeah, absolutely. Absolutely. Going back to the policy side, are there things that, there are a lot of aspects of biotech that are really new and emerging, and I think the governments at every level are just ill prepared to address because they're so new.
Oh, for sure.
What are some of the, I don't know, if I would love to just have a general sort of philosophical conversation around policy in biotech, specifically around what works, what's actually a good, what are some of the incentive structures in place today that are making it successful, and maybe what are some of the things that are holding the field back? It could be, you know, from a private business standpoint, holding back the innovation or the education perspective.
Absolutely. So integral in this is the field of bioethics. So what happens in technology, and this is all technology, the technology jumps ahead, and then philosophers start talking about it, and they meander after the technology, and then the legal system brings up the rear, right? And so there are tremendous ethical, legal, societal implications of all of this. And so we really need all the philosophers. I really want to start a program or a class in biotech for clergy to bring people who think about morality and think about ethics all day long, every day, to have the technical background in order to bring everyone into the discussion, because the future is, the question will be not, can you do it? The question will be, should you do it? Now, right now, biotech is mainly production of pharmaceuticals. Ethically, no one has a problem with that, right? There are people who have diseases that there are no treatments. Let me say that again, no treatments. Not that there are no cures. There's nothing that medical science can do. And biotech is stepping in and giving those people hope, and ultimately providing treatments, and potentially ultimately providing cures. And there are new innovations. One is called CAR-T, where you take the patient's white blood cells and genetically engineer them, and then put them back into the patient, and it chews up their tumor cells. And someone who was about to die a month later is tumor-free in a month instead. And so you can have no ethical problem with saving children. And this field has this tremendous potential for alleviating human suffering. The blind will see, the deaf will hear, the disabled will walk, and no one has a problem with that. Okay, what is the problem? Well, who's going to pay for it is one. That treatment of treating the little girl with leukemia with her own white blood cells, $500,000. There's one drug on the market. It's a manipulated, genetically engineered virus that takes a missing gene and puts it into the body and compensates for a genetic disorder. One treatment, $2.1 million. So anyway, the numbers are going to break the bank unless we can make it more efficient and bring the cost down. On the other hand, if you had, here are the ethical dilemmas. If you had a treatment and someone couldn't afford it, then what are the ethics of that? We probably should have, I don't know, a national conversation on healthcare, and maybe legislation that make it affordable. We could call it the Affordable Care Act. But no, what my comment is that my next career would be relativistic astrophysics before it would be healthcare policy, because astrophysics is so much easier. But anyway, so that's where society will weigh in, is the cost of all of this, and also again, there are just some things that you shouldn't do. There are some, there's some knowledge that you shouldn't have, especially in the way the brain works in neurobiology and manipulate how the brain is working. There's some wild science fiction stuff that you can think of, and we should think about that before the technology hits.
Well, I'm absolutely fascinated by the ethics and the philosophical rules that we create to sort of define what the policies should be. So I love talking about those kinds of things. And I wonder if you've settled on any of these. You brought up the T-cell treatment, which to me seems like not really pushing any ethical boundaries, although I think you use that as an example because of the cost being so high. But in terms of whether or not you should, that seems like as long as they're consenting, adults or the parents consent or whatever, that there seems to not really be too much gray area in terms of whether or not you should use that technology.
Not on the pharmaceutical side as much, but now you're talking about do it yourself.
Well, no,
we could go there, but
we will.
Okay.
We definitely will go there. We'll bookmark that. I'm more or less thinking there are other countries which do not share the value system that we have here in the West, who are not opposed necessarily to modifying a human embryo, for example, to give it maybe some sort of phenotype that doesn't exist otherwise, some sort of advantage over other humans that haven't been modified. There are, you can just let the brain imagine all the potential benefits of something like that in terms of extending human life and protecting from disease, but there are also some real risks associated with that as well. And I haven't really been able to iron out a philosophy to, when you get really into the details, I haven't been able to sort of figure out the boundary or how to define it. And maybe you haven't either, but if you have, I would love to hear what sort of guiding rules of bioethics do you have, or have you even had a chance to work some of that out?
Right. So my avocation, my hobby is looking at ethics because I'm more trained on the science side. But what has always struck me is that if you look culture to culture to culture, fundamentally different cultures have arrived at a lot of the main ethical decisions, right? The same ethical decisions. And so it should be positive for the individual. As you said, the individual should have a choice. There should be nothing that is forced upon someone. And I think that we should engage in these conversations earlier rather than later. So it's.
But I think there's a difference still when you say, should a mother have the choice to use genetic modification to cure her recent pregnancy of a potential genetic disease versus should she be able to modify the child to be super intelligent?
I view that as a boundary. Yes.
Yeah. So how do you define that boundary?
Think through. Okay. So
what's the rule?
Child. Well, be very, very careful with it. So I'm going to have a child and I'm going to modify them for intelligence. Okay. Well, now they're version human 2.0, but now their brother is coming along and, there's an upgrade. Now he's human 3.0. Okay, well now someone comes along and there's an upgrade. Okay, he's human 4.0. At some point you're going to cross the line, and so we have to have the discussion on where that line is. And again, let me go back to the core principle that in the near future, there will be many things that you can do. The question will not be, can you do it? The question will be, should you do it?
Yeah, one thing I always wonder too is how much of this is inevitable. A sort of Darwinian way of viewing this is that we evolved to our intelligence to create the technology. It's probably inevitable that we will end up in a place where we're modifying humans with super intelligence. which means that inevitably those people will carry on their genes, and the rest of us plebeians will die off.
Well, that of course is the fear, but it isn't anything that we haven't tackled, right? That you have women who go to the sperm bank and say, I would like to have my dead husband's child. Okay, well, tell that to your great grandmother. We're going to have in vitro fertilization, and so the daughter can't carry the child, and so she's going to have her mother is going to have her genetic grandchild, give birth to her genetic grandchild. Tell that to your great grandparents. There's all sorts of wild stuff. You can say, oh, I don't believe in test tube babies, I don't believe in vitro fertilization. Yeah, that cow is out of the barn. There are 2 to 3 million people walking around whose origin was not inside the human body, and there are hundreds of clinics in every state. You can argue the ethics of it, but the argument is over. People are doing it, and it's been done since 1978. So
yeah,
this isn't anything that we haven't tackled, right? In the past. That there are wild things already. They're just going to get wild, and we have to apply the same rules. Everyone should be reading their philosophers, right? What would Plato say? What would the utilitarians say? What would, we have tools. We have tools to deal with this. And again, the clergy have their own tools. We have the tools. We just have to do it. And we have to bring the public into knowledge of the technical parts of it so that the public can make intelligent decisions. And let me give you another example. Here in California, we just voted in favor of Prop 14. We are pumping $5.5 billion into stem cell research. That's in addition to the $3 billion that we've already put into it for the state of California alone. So stem cells, well, there are some ethical hesitations, especially in some populations, some philosophies against stem cells, but we're doing it. Well, we're doing it because the potential is so great to alleviate human suffering.
Yeah, absolutely. So, there's so many different places I could go there. So the stem cells, for example, may not be that controversial. There are different types of stem cells, and you can get different types you can trick the body's existing cells to become stem cells. Correct. But I think the most valuable ones are the pluripotent or omnipotent. I can't remember the exact names of them. from embryonic or embryonic stem cells, which is
and so far there really isn't a substitute.
Oh, okay. Yeah. So that research will incorporate the controversial, but presumably some of that funding will be looking at the alternatives, because that sort of will be easier to get the public support behind.
Correct. All of the public.
Yeah.
Again, I think the public is very understanding once you explain that this treatment or that treatment will alleviate human suffering. Okay, well, yeah, that's clearly ethical, right? You don't want people to suffer.
You work more with the public on a day-to-day basis than I do, and I can be a bit pessimistic about believing in the public's ability to get up to speed with some of these things. The public in general has a hard time understanding basics of a lot of different things. You seem to be more optimistic about the public and their ability to learn these things and form informed opinions.
I think the average person has had tragedy strike them. Some family member got cancer, or they know one of their relatives or a friend of theirs had a child born with a genetic disorder, maybe a very severe one. And so I think the average person knows what the stakes are. And if this technology can be communicated, that it isn't scary, that it really is people trying to help, that I think everyone will come along. So I am optimistic.
Yeah, that's really good to hear, and a good lesson too. If you can make the scenario personal to people and how it's actually going to directly impact their lives, that's where I think you can make a big difference. Circling
But
back,
I think you're right, though. I think
please.
one of the fundamental liabilities of the field is that it hasn't been able to tell stories. It hasn't been able to tell their story. That communication is essential. That there is this human need to put a face that is different than statistics, right? That you need to tell the story, and I don't think that this field has told the story very well. And then, but there is one story I'll talk about. The first biotech company, Genentech, and again, they're in our county. They have this beautiful founder's myth, using myth in the sense of a core foundation story rather than something that isn't true. But you have the scientist at UC San Francisco, Herb Boyer, sitting in his lab thinking, oh, funding is tight. How am I going to get money? And he gets a phone call from a 28-year-old entrepreneur, a recent graduate of the MIT Business School, Bob Swanson. He said, have you ever thought about commercializing your technology? No, I'm a venture capitalist. What's a venture capitalist? I don't know anything about business. Would you like to have a beer? Okay. And so they go to a bar in downtown San Francisco, and their 15-minute talk turns into a 3-hour talk. And by the end of it, they're writing on the back of an envelope, genetic engineering technology, Genentech. And, you know, it's this beautiful story. And, you know, and I think if you tell stories like that, and right, every company has a story like that. Somebody had an idea. And again, this is the genius of the free enterprise system when it works the way that it's supposed to work. That I have an idea. Okay, I don't have any money. Oh, I'll borrow some money. Okay, I hired a bunch of people, and I hired some lab space. Oh, now we're, fast forward 10, 15 years, we are making medicines that are saving people's lives. And we have a workforce, we're providing jobs for tens of thousands of people. And things are doing really well out of nothing, out of an idea. So just the magic of the free enterprise system, yeah, the way it's supposed to work.
Absolutely, it's incredible. I wanted to touch back on the DIY bio because we briefly touched on that. Are you familiar with the DIY bio space and some of the folks that are making headway? I would love to
I
just
have a little cameo. Let me put a plug in.
Yeah, please.
Let me put a plug in for the Netflix show, Unnatural Selection. It's a 4-segment series. I think it's excellently done. And I just came from a synthetic biology conference, and other people were complimenting it as well. And I have this little cameo in episode 2. But it talks about biohackers and do-it-yourself biology. And again, the question there is not can you do it? The question is, should you do it?
Yeah, and it seems that the biohacking, and I dislike that word. I don't refer to myself as a biohacker because it's an overloaded word and different people use it to mean different things.
But some of the people in the community embrace it.
100%. They live it.
They like the bad boy, label, right?
Yep, absolutely. Yep, absolutely. There seems to be, as there's these larger conversations around biotech, biohackers continue to be looped into that conversation, because I think, and this is just my perception, that there's the fear that people have around the technology is tied to the biohacking community, in the sense that if there are going to be people that push the boundaries, it's going to be people that are outside of the systems, the institutions that where it is being regulated and overseen. And I'll definitely check out your Natural Selection on Netflix. There's the Biohackers miniseries that came out of Germany that was on there.
Yeah.
It was fantastic. And it has all of the things we're talking about are incorporated in that. So it's very relevant. And then there's a Biohackers Citizen Bio on Showtime documentary that just came out that featured a bunch of biohackers from the Bay Area, all self-taught. So do you think, And a lot of my audience are self-proclaimed biohackers or from the DIY bio space. In part, this podcast is dedicated to sort of giving people in that space a voice, or people in biotech a voice as well. And one of the things I like to talk about is, what is the role that the DIYers have within the advancing the technology in biotech and in biology in general. And I wonder if you have any, just general thoughts around the role of the DIY bio community and biohackers, if you will, as well as, I could ask you other questions too, like where can we as an amateur community make contributions to the sciences? The first example that comes to my mind is the amateur astronomy community has made great contributions to the sciences. Often are the first ones to discover new asteroids and meteors that are on trajectory to hit Earth.
And comets. Yep.
And comets, yeah, absolutely. Yep. So maybe you could just chat a little bit about that.
Yes, absolutely. So first, I think that community is fantastic, especially bringing young people and exciting young people and bringing them into the field. As I said, we're going to need a huge workforce. This is the century of biotech. That it is comparable to the internet in 1990, right? This is going to explode. This is the century of biotech. Everything that you do will be touched by this. The clothing that you wear, the food that you eat, and medicines, of course. Now, right now, biotech mainly means pharmaceutical biotech, and that's where the money is, right? Medicines are expensive. You put a lot of investment in it. That's where the money is. But what is emerging, and it likely is going to be a $4 trillion a year industry, is the non-pharmaceutical biotech side. The synthetic biology. I'm going to take a cell, I'm going to manipulate it, I'm going to put in the gene for an enzyme from this organism, gene for an enzyme for this organism, the gene for an enzyme for this organism, and I'm going to feed it sugar, and it's going to transform, and then produce something useful out the other end. And that something useful probably will be worth not very much, which means you have to produce it in large volume. And so the do-it-yourself community, we'll say, can really help, I think, with these ideas where there isn't enough money to attract corporate ideas. You know, that really think of it as software in a startup. Look for a niche, and look for a niche that's different than the niche that the big boys are chasing. I think of something useful. It would be really useful if we could make this molecule. You know, oh, okay, well, I've got an idea. Let me look at the literature and find out what enzymes, what are the intermediate steps. And it's extraordinarily difficult because you have to put the genes in and have the enzymes expressed at the right level inside the cell. But you know, it's similar to the people that, I spent 200 straight hours writing code, you know, and just switch it. I spent 200 straight hours manipulating microorganisms. And so I think it's fantastic, especially in its ability to draw more people into the field and get them excited. And I do agree we have to democratize it. At the same time, everyone should be thinking, should I do this? And so we really, where I think the do-it-yourself community is missing is the self-introspection of the bioethics piece. You know, and again, it goes back to, I want to call myself a biohacker and be a bad boy. No, you don't, because that's going to lead to some sort of intervention by authorities. You don't. You want if you don't want to be regulated, self-regulate.
One good example of a project that I think the DIY bio community has done a lot of good in is with the Open Insulin Project. Have you heard about this?
Well, I've grown I got the cells and I've grown them.
Oh, fantastic.
Yeah. So out of Berkeley.
Yep. So insulin, for people who don't know, is incredibly expensive. I think for people that need insulin, it can cost upwards of $1,000 a week. So a group of people have gotten together, have engineered, is it yeast? I think
Yeah,
it's they've engineered
the
yeast.
Pichia. Mhm.
And
Genus Pichia. Mhm.
and I think that they've been working on putting together a plan for to be community bioreactors at the local level that produce insulin, purify it, and make it available. I think like $2 a week or something is what the projected cost is. Do you think we're ever going to get to a point where ideas like that actually come into fruition, or will there ever be a time where someone has a bioreactor in their house and they're producing some sort of enzyme or protein of interest?
Absolutely. Well, probably more in your garage, but yeah, that's the hope. And the insulin project, it's a noble project, but it's very difficult because you're going into pharmaceutical. These proteins, you can't have a protein pill because the protein has to have the right three-dimensional shape. And if you swallow a pill, the protein unfolds and it's worthless. So they have to be injected. Well, once you have an injected drug, now you are subject to all of the FDA regulations, and that sort of pharmaceutical space is really, really difficult. Not impossible, but it's really, really difficult, where I think the do-it-yourself community can help out much better is think about what enzyme would be useful for a consumer application. So an enzyme that digested dog droppings. So you put it on there and they disappear. Or think cleverly. There is a really interesting international movement called iGEM, which started at MIT, and you order different genetic elements from them, and then you put them together in a synthetic biology sort of way, and the goal is to produce something useful. And so every year, these college students will get together over several months and genetically engineer organisms, have them produce something useful, and then they all go to Boston and have a conference, put up posters and explain their posters, and then it's a competition and they hand out prizes and that sort of thing. I would love to see that put on steroids and have every high school kid do that. That something like that. Think of something, everyone, think of something useful.
I would like to be a part of it.
Absolutely.
I didn't know about it, but I was like, when I looked into it, I wish that there was a track for community biologists or DIY biologists, because I think then it gets really interesting, because you can bring together all of these people. Like, I come from a computing background. Who knows if I can get with the right people, what sort of amazing things we might build together for the competition.
No, you have the perfect background, because in synthetic biology, you think of biochemical pathways and circuits, and it's Boolean algebra, right? You have an AND gate and an OR gate or a NOR gate. And so you build together a circuit. You have exactly the right background.
Well, and you were saying the DIY bio community could do a lot of good by thinking about what cool enzyme could we create. And this is something I've been thinking about, because to me that seems like a computational problem. That seems like there should be a way to use machine learning to go and look at all the available proteins and enzymes and then run them against, do some sort of computation to identify them and then to match them. And my understanding is some of these companies are already doing that.
Yes, so it's machine learning, but it's also cellular learning, right? You have this entire evolutionary history of the cell. Okay, so think of a way that you can select the cells survive that do your process the best. Now, usually the cell's self-interest and your self-interest are different, right? And let's go back to the most ancient of biotechnology, beer. Okay, so your interest in having the yeast take the sugar from malted barley and convert it into alcohol to make beer. That's your interest. Yeast make beer. Their interest is yeast make other yeast.
Mm.
So if you run your yeast batch after batch after batch, you will have a degradation in the population for making beer, but those yeasts are better at making other yeast. That is, you have evolved in your fermenter the population. And it's classic evolution, right? It's change in a population over many generations. It's not a Pokemon evolution where this individual becomes something different. You know, it's a change in the population. Now, if you could use that to your advantage and set up conditions where your cells that do what you want them to are favored, you could have them learn. That is, you could have them evolve in your fermenter and optimize your conditions that way. So, and you can do that in your garage. So my recommendation to the do-it-yourself community is choose a niche. Think of something useful, something that there isn't really that much money in, but there is maybe a societal goal, because the companies will be,
the money will follow.
Yeah, and money should follow. Yeah. Mm-hmm. Yeah.
Yep. If you could find a good application to apply the technology to, you'll create a market.
But because if you think about it, again, this is the field of biotechnology. We do a lot of things that are really fundamentally dumb, right? We throw away resources into the landfill that should be recycled. Everything should be recycled. You should close the loop on everything. What you throw away should be the raw material for the next thing. You know, you have to close that loop, and you can only do it via biology. You can't do it through petrochemicals. And, you know, and using petrochemicals, of course, is putting greenhouse gases and global warming and, you know, existential threat to the planet. And this is the field that is the solution to that. And, you know, the people in your circumstance can be a part of that. And along the way, they're doing something that is really the most interesting human endeavor ever. And they are making their contribution to the societal good. And that's what they can do. But you have to find your niche, and you have to find a niche that companies aren't monetizing right at the moment. You know, and then
that could be tough. I mean, it's sort of like me sitting around and thinking, like, I can code, but what do I build? And that's the hard part, because pretty much I generally don't advise people to sit around thinking about what they could build. That's usually not a good approach to starting a business. More or less, you have to find something that solves a problem that you yourself run into or encounter. Solve it for yourself first.
What's
and
the
then,
problem? Mm-hmm.
Yep. And then see if other people have that same problem, and that your solution solves it for them.
Start it with the end goal in mind. Yeah.
Yeah. I wonder if maybe this is not something you've thought about, but one of my goals is to build a GMO organism right here in this lab. And it's something I've been working on, and it's taken me through some twists and turns. You know, there's a couple of kits you can buy that will let you CRISPR bacteria and make it fluoresce. And I'm doing those things because they're a great sort of introductory pathway into learning the steps involved. But they always keep how the sausage is made is a little hidden. The transformation plasmid, you don't really get to play a part in designing that. Do you have, this is a question for me personally, what would be a good next level up from that? Let's say I want to take my learning a little bit farther. I want to go beyond just having the kit and following the recipe guide and the steps and doing the transformation. I actually want to make yeast that produces something custom that I told it to make. What would be, do you have any suggestions on what that should be?
Maybe then, so the farther you go, probably the more equipment that you'll need. And so maybe your next
Keeping
step
that in mind
is a community lab. Like the one in Berkeley. There's one in downtown Baltimore, and so these community
You know, we
labs.
don't have one in LA, which is a little disappointing. But it's also something I've considered looking into maybe creating.
But you do have local colleges there that have equipment, and you can collaborate with them. And so and especially, you know, the closest community college to you, do they have a biotech program? If they do, then hook up with them, and they're likely going to be willing to partner with you. And, you know, if you have an organism, send it to me, I'll grow it for you.
Well, I'm trying to find the thing to design,
Yeah.
what to make. I actually think getting the plasmid not that hard. Doing the actual transformation, those protocols are already pretty well published and totally doable. And I'm just trying to generate titers of something just to go through the process. I'm not looking to do large scale purification of any particular proteins, which, as you said, would require quite a bit of equipment. So yeah, the other thing that I've run into as a DIY biologist, and it's probably not surprising, is I think you're a lot more open-minded, given that you come from the academia. You're a lot more open-minded and understanding of this community and what most folks are trying to do. I have reached out to a lot of folks, and I have several universities around me: UCLA, USC, and several LA area community colleges. They most of the time are not as open to someone like, for example, if I were to email USC, which I have, but let's say email them and say, hey, I'm working on engineering this yeast. Is there a way we could collaborate? I could use your lab and show you the research. I don't think that they would be open to that, based on what I've experienced so far.
Part of that is time, because the academic career is really brutal.
There are a lot of incentives,
yeah,
structures in place that are working against me.
Yeah.
On
the other hand, I think that if you are couching it in an education space, I'm trying to learn about this, and I'm going to bring what I learned to high school students and to middle school students. That might make them much more open to that. Whatever I learn, I'm going to pass on. That way, if you spend time with one person, you're really spending time with hundreds of people.
Absolutely.
So they might be more amenable if you couch it in that way.
You seem really passionate about biotechnology. Do you have a personal connection to this field?
I do.
That's driven you to have this passion, and especially for the education?
I always have had the passion for it, but my personal story is that my son, when he was 4, my youngest son, became deathly ill, and he was saved by a biotech program, by a biotech protein. And it was a protein that I had worked on when I was at Genentech. So
wow.
He, during the Thanksgiving break, he had become feverish, and he started to be confused, and I couldn't understand him, and so we took him to the local emergency room, and they couldn't figure it out, so they started giving him antibiotics, and he started developing this rash. And my wife said, "What's that rash?" And the physician took one look at it. He turned to the nurse and he said, "I need a helicopter for an airlift. I need it in here. I need it here in 5 minutes." And so they airlifted him to Oakland Children's Hospital. And so by the time I drove down there, he was in ICU. And you go to the door of ICU and you pick up the phone and, "Hi, I'm Jim DeKloe, Jefferson DeKloe's father." And they said, "Oh yes, we've been waiting for you. We'll send a social worker out to talk with you." Social worker, I don't want to talk to the social worker. The social worker came out and said, "You have to prepare yourself because you've never seen anyone this sick. He's in a coma, and he's really, really sick. The physician will come and get you when they are finished working on him, but it's pretty frantic there right now." And so they put in IVs. They put in 3 lines: a carotid artery, jugular vein. They put in lines everywhere. They were pumping in 10 different drugs. And then I got the diagnosis. He had meningococcemia, which is the bacterium that causes the most common type of bacterial meningitis when it goes around the spinal fluid. But in this case, it had jumped into his blood, and it caused widespread shock, that he was leaking fluid into his tissues, and all of the clotting factors in his body went off. So if you think of the deepest bruise you ever had, he was that way from one end of his body to the other, except his fingers and toes were turning necrotic black. So he was going to die that day. And then the physician said, we'd like to try something. We've tried it once before. We'd like to try a thrombolytic. And I said, a thrombolytic, you have to give them TPA, tissue plasminogen activator. They said, oh, you know what TPA is? There's no drug I know better than TPA. So give it to him right now. Well, I have to sit you down and explain the risk. I can tell you the risk. Give him TPA. So the calculus there is I had to trust my field and I had to trust my drug. And so they injected in this enzyme. TPA is an enzyme that digests blood clots, and they dripped it in an IV, and it went around his body. And he was less purple, less purple, less purple, and it digested all the blood clots, saving him from certain death. So if you want an advocate for biotech, you can find no better advocate than me.
That is an incredible story. How old is your son now?
He is 25, and he's in his first year in medical school.
Oh, okay. Well, congratulations to him and to you.
And then my eldest son graduated with a master's degree in synthetic biology from the University of Edinburgh in Scotland.
Of course he did.
Yeah, so it's all in the family.
Yeah, absolutely. And you just got back from the synthetic biology conference.
I did, yeah.
What's the buzz these days? Where is synthetic biology headed?
Yeah, so synthetic biology is heading in every direction in consumer fields. And so again, biotech started in pharmaceutical, and now catching up is non-pharmaceutical. And so we had some early expeditions into biofuels, but right now it's hard to compete with the lowest cost of oil that we've seen in a long, long time. And so biofuels is tough, but high value products rather than biofuels, cosmetic oils, and then there's a lot of really fun things, especially in California. There are companies that have bacteria that make spider silk. And so you make spider silk and you weave them into ties. And then this company, Bolt Threads, hired Paul McCartney's daughter, who is a fashion designer, to make silk dresses out of it. And they're making artificial leather out of fungal mycelium. And there's a lot, of course, not just Impossible Burger, but there's a lot of cultured meats and meatless food, and fish patties made from fish stem cells. And so it's exploding. It's really exciting, the whole field. And again, all of the conversation is close the loop. Close the loop. You don't want to start to make plastics with petrochemicals. Petrochemicals are carbon that came out of the ground, and when they're finally end up, that carbon's going to go in the air. You want to start with a feedstock that is sugar that took carbon out of the air through photosynthesis, and if it goes back in, then you're carbon neutral still. So a lot of it is the way to be sustainable, the way to save the planet is really through biology, and it's through synthetic biology, and it's exactly this. And so if you do it in your garage and you develop a interest in it, then maybe you start a company and now you're professional, and you've solved this problem. Again, everyone should look for a niche, look for a problem, and think about how can biology solve it, because biology solves it, synthetic biology solves it in a sustainable way rather than in a unsustainable way.
Fantastic advice. Jim, thank you so much for being on the podcast. It's truly a pleasure getting to know you and your background, which is incredible. And I'm so thankful that you took the time to speak with me this afternoon.
It was a pleasure for me. And again, to your listeners, this is a field for you. I would like you to consider going into this as a profession. This is the age of biotechnology. It will be for the next century. And we can really use you. It's a good career, and it's a rewarding career. And I know that many of your listeners that are younger aren't really as interested in a paycheck as they are with making a positive impact in the world. And so this is a place where you can do that. So Absolutely. Thanks so much for inviting me.
Absolutely. If anyone has any questions, how can they get a hold of you?
Oh, good. I'll give you my email, and they can just forward it. And,
okay.
Yeah.
Okay. Awesome.
I'm always open to answer emails, and Yeah.
Excellent. Thanks again, Jim. Have a great afternoon. You as well. Bye-bye.